Hey there, and welcome to another LeetCode problem. And we're going to do something a little different in this video. And so what I'm going to do is I have 10 easy LeetCodes, and I don't think it's worth making a new video for one LeetCode for easies, because they're usually pretty straightforward. What I'm going to do is I'm going to take groups of 10 easy LeetCodes and go over them as fast as I can, or just do the problems, and then I'll come back and go over anything I missed if I think I should talk about it some more. Okay, so we're going to begin with this one, and we're going to go with 10. Alright, so starting now. Given an integer array nums in your val, remove all occurrences of val in place, the order of elements may be changed. Then return the number of elements, turn on equal to val. Okay, so we are just taking every element that's not val. Okay, so that's pretty straightforward. So we're going to have a write 2 equals 0, and then a k equals 0, so 4. And we're just going to iterate through this array. If nums I does not equal val, then we're going to write it. Equals val. Or that's nums I. Then we're going to increment this. Increment this. Okay, I think that's it. Return k. Okay, this is annoying, stupid Python. And this new LeetCode keeps having weird tabs. Okay. Alright, moving on. And we're going to go over the space and time complexities after we finish. So, write a function to find the longest common prefix among the rare strings if there's no prefix. Okay. So what we're going to do is we are going to... Yeah, okay, so if when strings equals 0, or just if not strs, return this. So we're going to have a prefix equal to the first element, and we're just going to keep subtracting down as we go. So prefix, okay, prefix equals tr's 0, then 4 is tr, or for item, and tr's 1. We're just going to iterate character by character, and then as soon as they're different, we're going to make the prefix smaller, so 4, and then we're going to have a new prefix, so equals this, 4 char in length, prefix, if char, the subject should be I, if item I. Actually, I wouldn't want to do that. I'd want to make sure. So, yeah. So if it's too long, I is greater than or equal to length item, break here. And then here we do if item I equals prefix I. That means this is fine. So plus equals item I. And if they're not equal, we break here as well. Okay, then we just have a new prefix and we keep going, and I think that works. So let me just return prefix here. See if I screw anything up. For I, no. Ugh. Okay, let's see. Oh, right, I forgot one more thing, I think. Yeah, definitely. So then we just have prefix equals new prefix. Okay. Okay, next one. Contains duplicate. Given an array, return true if the number Okay, this one's really easy, so just call duplicates or something to set for num in nums. If num in dupes, return true, and then just, why does it keep doing this? Okay, so if it's in there, return, otherwise add it to the set, so num, return false. Okay, yeah, some reason it's still being annoying. Oh, right, so that, that's this. Okay, alright. Okay, two sums, so this is pretty straightforward again. So we have two sums, probably the most solved LeetCode problem. So we have visited equals some hash map for I in range length nums. If target minus nums I and visited, return visited this. And so it's the first index I, otherwise we just add it in. So nums here, it's nums I equals I. And that's it. Okay. Length of last word given string s consisting word and spaces, return length of last word in string. Okay. So if it's consisting, okay, so first we need to get rid of these things. So we could just have a split, but if we split, then we have to store something. I think strip also works. Yeah, pretty sure. So s.strip. Let's try to, I forgot exactly what this looks like, but let's try to do this. Print s.strip. I might have to make it equal to it or something. Okay, and then just return something. So there's another way to do it without using strip, or we just go back, but 5. Okay, so fly me to the moon. Let's see how. Yeah, so this does get rid of leading and trailing white space. So then all we have to do is just, so we do this s.strip, and then can it be an empty string? So s equals 1. There will be at least one word. Okay. So then we just do location equals s minus 1, while location, or s location is, actually this is greater than or equal to, greater than 0. Do I want to do equal to? I think I'd want to do greater than equal to, yeah. And s location does not equal this. Location minus equals 1. So then, if we're here, for example, so if this was 1, 2, 3, this is 0. So I think it's 3. We're always going to be at the index before the last index, guaranteed. So it's going to be, if this is 0, 1, 2, 3, and we want it to be 2. So just return we don't actually need to, yeah, so we can have some kind of res, so res equals 0. So I think this would be, if we start at the last character, we add 1, we add 1. Yeah, so if we start here, do this once, go here, do this once, go, I think this is just res. So Oh, let's see. Oh, right. So this is when s. Oh, okay. So what am I outputting here? 0. Oh, I probably have to do s equals s dot strip or something. Actually get rid of the zeros. There we go. Okay, this definitely could have been an easier way. I can just say the easier way to do it, instead of doing this s dot strip, I could just say if it's a space, go back. Okay, so given two strings, return if it's a subsequence. Okay, so ABC true, deleting some characters. Okay, straightforward again. So we have a left and a right equals 0, 0. Then we are done when we iterated through um, this big string, I think. Let me think. No, we're done when we iterate through the small string. Yeah, because as soon as we iterate through the small string, that means there is a, yeah. Okay. But we might have a no solution, so I think we actually have to iterate through the right one. So while right is less than length t. So here we need to check if we already iterated through the left string. So at any time if left is greater than or equal to length s, return true. Okay, so now we just check if they're the same. So if s left equals t right, s plus equals 1. Okay, and this is always, so this is left, right plus equals 1, and then if we are done with both, then return return left greater than equal to, or just equal to minus, I think that's it. Yeah. Okay, next one. Replace every element with greatest element on the right side. Okay, straightforward enough. So we just have right side equals -1. Then for in range length r. So we need a temp as well. Oh, we don't. So we need right r I. So the right is going to be max of right and ri, and then the left, or the arrow, is going to be right. Okay, I think that's it. After doing so, return the array, so return r. So let me just make sure, right? Max r, ri, yes. Okay, let's try it. What the hell? Why do we have a, that's weird. Oh, because we need to go backwards. Classic. Okay. Okay. Given an integer array, you want to create an array of length 2n where ands I equals nums I. Specifically concatenation. Okay. So this is really easy in Python. So it would just be this, I think. Yeah. Okay, valid anagram. Return true, false. Okay, so in a valid anagram, the count of every letter is the same. So we can just do left equals counter of s, and counter is going to be a dictionary of the count of every letter. So right equals counter of t, return left. If they're anagram, they should be the same. So there we go. Okay. Okay, last one. Unique email address. A valid email consists of a local name and domain separated by an at. Besides lowercase letter, emails contain this. Okay. So Alice at LeetCode.com. Alice is a local name. LeetCode is a domain name. If you add periods between some characters in local name, mail sent there will forward to the same address without dots. Okay. So Alice.z. So anything to the left when you have a period is ignored. And then when you have a plus, everything after the plus will be ignored. Okay, so for example, m plus, so this dot gets ignored, my d, okay. This rule, it's possible that both of these rules at the same time. Given an array, return the number of different addresses. Okay, so the number of different addresses, so we're going to want a set here, so just like addresses, we're going to have a set, and then we're going to just keep adding, once we concatenate this address, we're going to concatenate that to a set. So for email in emails, so what's our priority here? If we have a dot, we ignore it, okay? But if we have a, I think our biggest thing is the plus. So if, or we have to probably do for character, something like that. So, and then we're going to have a string email. So this is just going to be like new mail or something. Equals this for character. I don't think we need an index. Do we need an index? Yeah, we do. For I in range length email if email I equals. So our first character that we're going to look for is the at, I think. Yeah. So if it's at, then we just do new mail plus equals email I plus 1, where you just return the rest of this email thing here. Oh, I think we need the add as well. Yeah, so we do need that. Okay. So yeah, we need the add as well. So email I, just go forward, break. Now our second thing we need to care about is the circle. So email I plus. What we need to do is we need to go until we are at this at. So while email I does not equal at I plus equals 1. Okay, so we have I plus equals 1. Then we do this thing again. Break. Next case, we handle the dot. So if we handle the dot, we do nothing. And so we can just say if our character isn't a dot, then we append, and if the dot, we don't care, so we just move on. So if email I does not equal the dot, then we append the character. So this equals email I here. So that should do it, and then we just return the length of addresses at the end. So let's see if that works. On indent, yep. That's this stupid tab. Yeah, hopefully that's all tabbed correctly. Expected. Okay. Ooh, what do we have? Yeah, let's actually print. Just to make sure. Or wait. We never actually added to our visited set. Yeah, that's right. That's what we did wrong. Okay, so there we go. Hopefully that's good. Apparently not. Okay, let's print it. So what do we have? It's error. Test. Test email Alex. Test email Bob. At Kathy. Okay, so we have, this should be test email at LeetCode.com. This should be test email at LeetCode.com. Okay, I see. Okay, so it looks like test email. Yeah, we have a bunch of things here. So we have test email Bob. But the problem is, yeah, so we're not handling the sign correctly. So while email does not equals I plus 1, new mail plus equals email I plus break. It should work, I think. But yeah, for some reason we're not handling that correctly for sure, so clearly. And also for some reason we're not resetting that, which is also kind of interesting. Where we do reset it, it's almost like this is somewhere in the wrong spot. No. That is strange. Okay, so let's see. This is new mail. For I and ring, okay. New mail plus. That should be fine. If it's not a dot, that should be fine. We keep appending to it. New mail plus equals email I plus. Okay, so I think the problem is we aren't really appending correctly. So we're doing, yeah, we're for some reason appending here anyway, which is strange to say the least. Yeah. Okay. Oh, wait. Classic. Okay. That's why we're appending. So now we should be good. I think, yeah. Okay. So the problem is, I was like, are we doing this range loop? The problem is we were appending every time until we got to the at where we just need to get there once. Okay. So now let's go over the space-time complexity of all these real quick. So for this first one, for remove element, what are we doing? We are just moving everything to the back. So space and time is going to be, so it's just going to be O of n, where n is the length of the array. Space. We didn't initialize anything else, so this is just O1. Okay, let's take a look. Longest common prefix. And for most of these easies, there's definitely like a more efficient solution. Usually you just kind of have to write something that works. So time. So I could definitely, if I took more time on this, make something more optimized. So we're iterating through this strings. We are comparing every single letter. Yeah, so we're comparing every single letter. And then we are, so it's going to be something like length of strings times the worst case scenario, I guess they're all the same. So it's just length of max, or max length of a word or something like that. Something like that, where let's say if these are all flower, then it'll have to compare every character. So just length of the strings times the length of the word. Space. We just created a string and that's it, so we didn't make anything else. So O of 1. Okay. Next one contains duplicate. So we do have a visited set here. So, but for time is O of n. We are just iterating one time. Space is O of n as well because we have a visited set. Okay, let's take a look here. ToSum. So time is O of n. Space. We have a dictionary, so O of n. Length of last word. Okay, let's see here. So we're taking last word. So this is just going to be O of n as well, because technically we can have one huge word. So n is just going to be the length of the string. Space. We are creating the string. Or are we? No, we're not creating a string. We just have an index, so it's just O of 1. Okay. Is subsequence. So we are creating, what are we creating? We're not creating anything. So time is, we just have pointers. So O of T, because T is the longer word. And then space. I think T is the longest word anyway, right? Yeah. It doesn't necessarily have to be, but this is only 100th to the fourth, so usually. Space is O of 1 because we didn't create anything, we just made some pointers. Okay, replace elements with elements on the right side. So here is time O of n. We loop through the whole thing. Space O of 1. Okay. Concatenation. So if you are counting, so for time it's going to be O of n, because to make this new thing we do have to loop through this nums to make it. Okay, and then so time. All right. Space. If we are counting making this output, it's going to be O of n because we had to make a new variable with that. So it's going to be 2n, but it'll run down to O of n. Okay, valid anagram. So we did make this counter for each, and so technically it's going to be O of, there's going to be 26 keys, which will be a constant number, and then for each key there's going to be, so it's technically going to be 26 and then some number. So I think this actually rounds to O of 1 because there's only going to be 26 letters and each letter will have a number. So I think that rounds down to O of 1. It's going to be constant. So actually, sorry, so space would be O of 1 and time. I might cut out there for a second. So for time, it's actually going to be, we have to go through both of these strings to get the counter of each character. So that's just going to be that. And then space should round down to O of 1. And then for this email thing, so time, we need to go through every single email, and then we also need to go through every single letter in the email, roughly, because worst case scenario, we have some huge thing in the front. Like let's say we have, so how long is going to be? Emails length, email, yeah, so it's each one's 100 characters, but let's say the thing before the at is most of it, then we're going to have to go through all of it. But either way, we have to get it. So, okay, so time is going to be O of length of emails times length of an email. So whatever we have to go through every single character. So that's going to be that. Space. So we're making a string, and we keep reusing a string, but we also have this addresses set. And so this addresses set, worst case scenario, is going to be the same thing where, let's say every email is actually unique. Then we would take every email and put this in this addresses set. So this would be the same thing. Length emails times length of an email. Okay. All right. So I think that's all for these problems. And if you have any questions on any one problem in particular, I know I ran through these kind of fast just to show you that once you get good at these algorithms, you should be able to do an easy problem in under 10 minutes, like comfortably. So that's the goal. And if you have any questions about any one of these problems, you can write in the comments, or if you want me to make a lot of these problems also do have optimal solutions, which I may not have done. So if you want something like that for one of these, you can also write in the comments or ask. And yeah, so I'm going to make more videos, and like and subscribe, and I'll see you in the next one.